Welcome to This Explainer. You know, it is incredibly easy to just assume that because a company builds wind turbines, they automatically get a perfect green score, right? I mean, it's wind power. But institutional investors need hard data, not just good intentions. So today, we are going to break down exactly how global finance measures the true sustainability of the wind power industry through the lens of the SASB standards. We're going to see how they grade massive clean energy developers on literally everything, from worker safety all the way down to critical mineral supply chains. Okay, let's jump straight into our blueprint for today. First, classifying wind tech, RWT. Then, workforce health and safety. Next, navigating ecological impacts, followed by materials, sourcing, and efficiency. And finally, tracking industry activity metrics to see how it all comes together.
All right, Section 1, Classifying Wind Tech, RRWT.
Before you can measure an industry, you really have to precisely define it. So the crucial point here is that professional investors use a highly structured framework called the Sustainable Industry Classification System, or SICS. Under this system, wind tech is officially categorized within the renewable resources and alternative energy sector. And the specific industry code for that, it's RRWT. This code applies to companies manufacturing turbines, blades, and towers, as well as the folks developing and managing wind energy projects globally. Basically, this RRWT tag is the master key that unlocks all the specific sustainability expectations for these companies. And the authority behind these metrics is absolute. The SASB standards actually sit under the stewardship of the IFRS Foundation now, which means the International Sustainability Standards Board is the one maintaining these rigorous reporting rules. This isn't just some arbitrary list of good deeds. It is a globally recognized financial reporting framework used to assess very real material risks that affect a company's cash flows and cost of capital.
Section 2, Workforce Health and Safety. Let's move from the macro classification right down to the human element.
It's a vital question. How safe actually is it to build and maintain these massive structures? Wind farm operations and maintenance involve incredible physical hazards. We are talking about workers operating at extreme heights, dealing with huge moving mechanical parts, and managing high-voltage electrical risks. So this isn't just a moral imperative. A poor safety record leads to operational downtime, and that directly impacts a wind farm's insurance and operating costs.
Now check out this highly specific number, 200,000. Under the SASB standard RR-WT 320A.1, companies have to calculate their incident and fatality rates based on exactly 200,000 hours. Why that number? Well, it represents exactly 100 full-time workers putting in 40 hours a week for 50 weeks a year. It creates a perfectly standardized baseline. That means you can compare the safety record of a small regional developer with a massive global manufacturer on a completely level playing field.
So what exactly are they measuring against that baseline? They track the total recordable incident rate, or TIIR, and the fatality rate. But here is the crucial detail. They must report these rates for both direct payroll employees and contract employees. In the wind industry, tons of specialized installation and maintenance is done by third-party contractors. By forcing companies to track everyone on site, there's no hiding safety issues behind subcontractors. Demonstrating a pristine safety record across the board is frequently a make-or-break requirement when they bid for new projects.
Section 3, Navigating Ecological Impacts.
Okay, this is a fascinating paradox. While wind is literally the definition of clean energy, the physical process of building and spinning massive turbines can face fierce local opposition. Communities might push back on noise or visual aesthetics, while ecologists often raise alarms about threats to endangered bird and bat species, or even the impact of offshore developments on marine ecosystems. If regulators or communities get concerned, permits get delayed, and that directly crushes a manufacturer's demand.
Investors actually track these controversies directly on the balance sheet. They aren't just looking for angry letters to the editor. They look at metric RRWT 410A.2, which measures backlog cancellations. If a customer can't get a permit because of community opposition to noise or maybe wildlife risks, and they have to cancel their turbine order, the manufacturer has to report that exact financial loss. It translates qualitative community pushback into cold, hard financial data. To prevent those costly cancellations, developers have to get seriously innovative, and this is where the engineering gets incredible. They are integrating physical tech like radar detection and ultrasonic transmitters to deter wildlife. They're also developing control software capable of sudden curtailment, meaning the turbine can abruptly stop spinning if a flock of birds approaches. They even strictly manage acoustic impacts by monitoring the average A-weighted sound power level, measured in decibels.
Section 4. Materials, Sourcing and Efficiency. Let's look inside the turbines themselves. There is a massive tension at the heart of wind technology: sourcing versus efficiency. Modern direct-drive turbines are super reliable, but they require significant amounts of critical minerals, things like neodymium, tantalum, and tungsten. These are heavily subject to geopolitical supply chain risks. On the flip side, turbines are getting huge to capture more wind, meaning they use massive amounts of bulk materials like steel, aluminum, and carbon fiber. The challenge: maximize power output while using way less of these heavy, expensive raw materials.
Because critical materials have a super low substitution ratio and are often concentrated in just a few countries, manufacturers must clearly report their management strategies. How are they diversifying suppliers? Are they strategically stockpiling essential minerals to weather price volatility? What about researching substitute materials or investing in recycling tech? It's all about proving to investors that a geopolitical bottleneck isn't going to suddenly shut down their entire production line.
But what about the massive bulk materials? Well, to prove they're succeeding on the efficiency side, companies report a highly specific metric: average top head mass per turbine capacity. You calculate it by taking the mass of the top head, so the nacelle and rotor, in metric tons, and dividing it by the turbine's megawatt capacity. Basically, how many tons of metal does it take to produce 1 megawatt of power? By tracking this, companies prove they can generate more power without simply building heavier, vastly more expensive machines.
Section 5. Tracking Industry Activity Metrics.
Let's zoom out to see how all this is contextualized. This is the underlying machinery of global finance right here. When a wind tech company publishes its sustainability report, it is not a free-for-all narrative. They use exact accounting codes to map their data. It requires strict units of measure: rates for safety, decibels for noise, presentation currency for canceled orders, metric tons for materials. It enforces complete standardization across the board.
But raw data needs context. That's why we have activity metrics. Investors use these, like the raw number of turbines delivered, the aggregate megawatt capacity, or the financial amount of the turbine backlog, to normalize the numbers. It accurately scales the data. This means an analyst can compare a boutique offshore developer in Europe with a massive onshore manufacturer spanning 3 continents, and they can do it on completely equal footing.
As we wrap up this explainer, I want you to really think about this. How do standardized metrics change the way we value the companies building our future? We talk about the green energy transition in broad, idealistic terms all the time, but as we've just seen, true sustainability requires strict, standardized math to hold companies accountable. It begs the question: as wind turbines get larger, more complex, and way more mineral intensive, will engineering innovation be able to outpace the ecological and geopolitical costs? That is absolutely the real test for the RRWT sector moving forward. Thanks for joining me on this deep dive.